Force and Changing Momentum, and Newton's Third Law by KayScience.com. So we know F equals m times a. The resultant force equals the mass of the object times by its acceleration. And we know that a equals v minus u over t. So the acceleration of an object equals its final velocity minus its initial velocity divided by the time. And we know that momentum equals mass times velocity. So the resultant force acting on an object equals its mass times its acceleration. As you can see here, acceleration equals v minus u over t. So you can actually write the resultant force of an object equals the mass of the object times by v minus u over t. So this can be rewritten as the resultant force F equals mass times final velocity minus the mass times the initial velocity divided by the change in time, t. Mass times velocity equals an object's momentum. So m times v, mass times the final velocity, is the final momentum of the object. And m times u is m times the initial velocity of the object, which is the initial momentum of the object. So if we write it as F equals mv minus mu divided by change in time t, this can be written as F equals the mass, which remains the same in both mv and mu, times by the change in velocity, delta v, where delta v is the same as saying v minus u. And then we can divide m times the change in velocity by the change in time, delta t. And remember, m times the change in velocity is the change in momentum. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. Recall the equation F equals mv minus mu divided by change in time. This is a ball with a mass of 500 grams. So the ball is moving with a velocity of 5 meters per second, and it's moving to the right in this example, so we give it a positive velocity, so it's plus 5 meters per second. And this is the initial velocity of the ball, so it's u. This footballer is going to kick the ball in the opposite direction to which the ball is moving. And when she kicks the football, the kick lasts 0.01 seconds. So the foot and the ball are in contact with each other for 0.01 seconds. And at this point, a force is exerted on the object, and this causes the object to change direction and its speed, so it changes its velocity. So the ball is now moving with a velocity of 15 meters per second to the left, and this ball has a mass of 500 grams. So the question was to calculate the size and direction of the force exerted on the ball by the player. So recall the formula. Force equals mass times final velocity minus mass times initial velocity divided by the change in time. The mass of the ball is 0.5 kilograms, not 500 grams, but 0.5 kilograms. The final velocity is not 15 meters per second, but it's minus 15 meters per second because it's moving to the left. Because it's a vector quantity, you must take into account its direction. So the initial velocity of the ball is 5 meters per second. So it's 0.5 kilograms times 5 meters per second times 5 meters per second. And you divide this by the time the ball was in contact with the foot while the force was being exerted. That's 0.01 seconds. We can simplify this equation by writing it as F equals minus 7.5 kilogram meters per second, which is the object's final momentum, minus the initial momentum, which is 2.5 kilogram meters per second. And we divide the change in momentum by the time the ball was in contact with the foot. So that's the time that the force is being exerted on the object, which is 0.01 seconds. So F equals minus 10 kilogram meters per second divided by 0.01 seconds. So the force exerted on the ball by the player is minus 1,000 newtons, or 1,000 newtons to the left. Remember, the size of the force is 1,000 newtons, and the direction is to the left. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. Before the collision, the 0.1 kilogram white ball was moving with a velocity of 4 meters per second. And the red snooker ball, also the mass of 0.1 kilograms, was stationary. So during the collision, the white ball is going to exert a force on the red ball. The white ball is going to exert a force on the red ball. And the red ball is going to exert an equal and opposite force on the white ball. This is Newton's third law. And the time the white ball and the red ball were in contact with each other was 0.1 seconds. So that was t, the time. So after the collision, the white ball is now moving with a velocity of 1 meter per second. And the red ball is moving with a velocity of 3 meters per second. So we can now calculate the force that caused the change in velocity of each ball. Using the equation F equals m times v minus m times u divided by t. So to calculate the force exerted by the white ball on the red ball, we must calculate F. So u, the initial velocity, is 4 meters per second. The final velocity v after the collision is 1 meter per second. And the mass of the white ball is 0.1 kilograms. And the time that the ball was in contact with the red ball while the force was being exerted was 0.1 seconds. So F equals m times v minus m times u divided by t. So the mass is 0.1 times by v, the final velocity of 1, minus the mass of the ball, which is 0.1 kilograms, times by the final velocity, which is 4 meters per second. You divide that by 0.1 seconds. So that's 0.1 minus 0.4 divided by 0.1, which can be simplified to minus 3 divided by 0.1. So the force exerted by the white ball onto the red ball is minus 3 newtons. So to calculate the equal and opposite force exerted by the red ball onto the white ball, we must recall the initial velocity u, which is 0 meters per second, the final velocity of the red ball, which is 3 meters per second, the mass of the red ball, which is 0.1 kilograms, and the collision between the red and white ball lasted for 0.1 seconds. So recall, so F equals m times v minus m times u divided by t, which is 0.1 kilograms times by 3 meters per second, which is the final velocity, minus 0.1 times 0 meters per second, which is the initial velocity, divided by 0.1, which is the time the balls were in contact with one another. You've then got the change in momentum, which is 0.3 kilogram meters per second minus 0 kilogram meters per second. Divide that by 0.1, which equals 0.3 over 0.1, which gives you a force exerted by the red ball on the white ball, which is 3 newtons. So the force exerted by the white ball is negative 3 newtons. And the force exerted by the red ball is plus positive 3 newtons. So the force exerted by the white ball is negative 3 newtons. And the force exerted by the red ball is plus positive 3 newtons. So as you can see, the forces that act on the two balls during the collision are equal in size but act in opposite directions. This is Newton's third law. Press pause to answer the questions. The answers will follow. And if you're stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes.